Hi everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be learning about corrosion and specifically rusting for GCSE chemistry. I hope you guys find this video helpful. If you do, feel free to let me know in the comment section. Give the video a thumbs up if you enjoy it. And if you'd like to share this with someone else to help them with their revision, feel free to do that as well. And thank you so much if you've recently subscribed. It's amazing to have you here. I do appreciate everyone's support. So thanks again. Really, really appreciate it. And it does help the channel out. Okay, let's talk about it. So a question I have for you guys, have you ever worn jewelry for a while and you've come back to that piece of jewelry later on, a few months later, and you've noticed that parts of it have turned a green color, and it's almost through wear and tear? Some jewelry does this and some jewelry doesn't. Well, this is because of something called copper oxide, and this is essentially where corrosion has occurred through moisture on the skin that's reacted with certain types of metals such as copper that is present in that jewelry type. And this is often usually costume jewelry this occurs in, so jewelry that's perhaps a bit cheaper and more affordable, as opposed to ones that are made of real gold or real silver or an alloy in some way. So we're going to talk about this in more of a realistic scenario, but this is more of an everyday occurrence where you actually may have seen corrosion before. And like I say, this doesn't happen to lots of metals. So if you think about cutlery that you may have, like your spoons or forks or knives, they don't often have corrosion like, say, jewelry might. And we're going to explain why that is now. So why do some metals corrode? Like I said, it's because of something called corrosion. And this is when metals are oxidized when they're exposed to air. So they react with some oxygen in the air. And sometimes they can even react with some moisture or water as well. And this can cause almost like a weakness to that metal. And often the appearance changes by going green or an orangey color, depending on what metal is oxidized. So metals, like I say, react with oxygen. And you can see, for example, we have a group 1 metal here. We have got sodium, and it reacts with the oxygen O2, and it forms this Na2O, or sodium oxide. And we can actually observe this if we were to get a piece of sodium. It's highly reactive. Like I said, it's in group 1. And if we were to cut it with a scalpel, because sodium is a very soft metal, you may have seen this in class actually, if you've ever looked at the group 1 metal experiment, where you place a teeny tiny piece in water and it starts to fizz and skid around the water surface. You'll see that actually if you cut that piece of sodium, it actually has a very shiny interior until it is exposed to the air around it, and then it starts to oxidize and go dull. So that's why we actually keep sodium in oil, to stop this oxidization, but also we want to avoid it going in water because it's highly reactive as well. And this is the same with other group 1 metals like potassium or cesium or lithium or whatever. And they all do corrode over time, especially when exposed to oxygen. So rusting is another example of corrosion. Corrosion just means when metals oxidize, but rusting is a specific example of corrosion where iron or ferrous metals like steel, which is a mixture of iron or an alloy, they actually are exposed to that oxygen. I have done a whole video, like I said, on alloys, so I can put that in the description box or in the card somewhere if you'd like to go over that again. So rusting, like I said, iron and oxygen react together. We form something called iron 3 oxide. And this is that kind of orangey color that you see on certain tools, perhaps like a hammer, which you see here. They can kind of corrode over time, and it does weaken them as well. Sometimes you even see this on like cars or even on like bicycles if they've been left out and they've had some exposure to the elements. And it's the same in the case of iron, oxygen, water. We can get something called hydrated iron oxide. And it's just a similar reaction, just in this case it's hydrated, so there's been some water present as well. And often, like I say, this actually affects a lot of outdoor objects that are metal or metallic, especially ones that contain some iron in it. So how do we actually prevent this from happening? Because corrosion and rusting are not things we'd really want. We don't want our objects to get damaged. So how do people protect against this? So how do we actually prevent corrosion? Well, one of the ways is to use a physical barrier, so something that will physically prevent oxygen or water from attaching to and reacting with that metal. So physical barriers could be things like oils, plastics, paints, and this literally coats the object and stops that corrosion from starting in the first place. And like I said, that's how we actually stop sodium from reacting with oxygen and oxidizing. We keep those particular group of metals in oil, and that just prevents any oxidization that could occur. The other method we could use is electroplating, and this uses a technology called electrolysis, where we essentially put a very thin piece of the metal that we want to preserve, we cover it with another metal, and this essentially stops the object from rusting or corroding over time. Electroplating is actually something that's done a lot in jewelry manufacturing to stop that green color from occurring. And this, like I said, it just uses different electrodes to allow the iron to be completely coated, and this is a whole another topic actually, is electrolysis, and I haven't done videos on them yet, but if you would like them, let me know in the comment section, and I'll definitely do some videos on electrolysis, because you do need to know it for GCSE and how this works. It's a really important technology. Another thing that we could do is something called sacrificial protection. And as the name would suggest, there is some sort of sacrifice going on, if you will. So what do I mean by that? Sacrificial protection is where another metal is used to oxidize with the outside environment, with the oxygen, as opposed to the metal that we're trying to protect. And this essentially, this metal acts as a sacrifice, if you will, to the oxygen and goes, okay, you can oxidize me. The metal inside that I'm coating is not going to be affected. And then that sacrificial layer will be removed and the process occurs again. So sometimes this is done to stop the rusting of objects that are important to us for whatever reason. And sacrificial protection is one of those examples you need to know. We also have this idea of galvanizing as well. So this is when iron is coated in zinc, and zinc is much more reactive than iron. If you look in the reactivity series, you'll see that that is the case. And that's why zinc is coated over the top of iron to protect it. Like I say, again, I have done loads of videos about these sorts of topics. So for example, the reactivity series, group 1 metals, those sorts of things. So I'll link all those videos for you in case you want to go over and revise any of this, because there's a few things that link together and it's just nice to do that, isn't it? Okay, I hope that video was helpful, albeit a shorter one. If you did enjoy this video, feel free to let me know in the comment section. Give the video a thumbs up, and also please do subscribe if you haven't already. Thank you again for all your support on my channel, and I've been the GCSE science teacher and you have been curious. Have a fantastic day, and I'll catch you in the next one. Take care.